Welcome, everybody. This is our weekly OPI Lifecycle Provisioning Technical Working Group. So looking at the Slack channel, we have three topics to discuss today. One is unique VFPF identification, kind of new topic that we started discussing several meetings already. So not sure if Eyal, Oscar, you prepared today for NVIDIA kind of view on the identification process.
Yeah, so I came better prepared today than previous times. Okay, go over the agenda and then we can talk about what I found out.
Perfect. Okay, good. Then we have our usual latest topic that we talk about is a boot sequencing. I want to go over again the new reboot page that I created, and we need to go back to the initial boot coordination page and see how can we improve that, and can we actually make a decision finally on the approach. And the third topic is Samer from ARM. We'll continue talk about secure boot, root of trust, TPM, and device attestation of DPUs and IPs. Any addition to the agenda that people feel that we need to address? Well, that's good enough. I'm just looking for feedback. I want everybody to have a voice and opinion in this group. Okay, I guess it's okay by everybody to have that as an agenda. So let's deep dive into the first item. Eyal, yeah, take us from here.
Yeah, just a second. I will be sharing my screen, okay?
Absolutely.
Can someone confirm that you guys all see?
Yes, it's up.
Okay, so this is again, I saw this for the first time this morning. This is all public documentation. But basically, what it shows is how interfaces are being, what's the naming convention inside the DPU. So there is the interfaces on top of the functions that are enabled on the DPU itself, and there are the interfaces that represent interface that are on the host. So this is can you see my cursor as well?
Yes.
Okay, so this is the DPU part, and this is the host part, or the guests, and basically, while there is correlation between the two, there is no one-to-one mapping, and reason being is that two reasons. First, these interfaces sometimes or often exist before these interfaces exist, even before the functions are being enumerated. For example, you want these interfaces to exist while this guy is waiting for a PXE boot. Maybe you even want to configure the guest through the representer ports before it can kick off PXE boot. And of course, at this stage, you don't have operating system running with a PDF assigned. Second reason that you can't have hard correlation between BDF here and the interfaces names here is that you want these to be stable. And BDF can be assigned differently depending on operating system and hypervisor version and type, even across soft reboots. We don't want a soft reboot on the guest to change interface name suddenly on the DPU, right? So there is no hard correlation between the two. The convention is such that we have, so this is an interface name. It's just shown as two names, but that's an example of an interface name. Let's look at this one. This is better. So control 0 or C0, I think it's on the latest versions of the software, represents the host number. So you will see C0 to C3, for example. PF0 is, it's only distinguished from PF1, but again, theoretically, it doesn't even maintains the order of how PFs are listed on the guest. And again, because we have no control or any way to guarantee anything here, it depends on the operating system BIOS, etc. Same goes for the VF number or the SF number, it's all the same. Moreover, if you will have two DPUs on the server configured identically, same number of hosts and same number of PFs and same number of VFs or SFs on the guest, it will guarantee that inside those DPUs on the ARM complex, you will have interfaces that has exactly the same names across the two DPUs. The two DPUs are not aware that there is two DPUs, which makes the mapping even harder, right? Because you will have C0, PF0, VF0 on one DPU, you will have exactly the same interface name on the other DPU. But of course, these correspond to different BDFs on the guest, right? So what I was basically told is that it's up to the operator to make sure that they somehow have a software way to map between the two, or of course, if the industry comes up with a spec, but that's not an easy problem to solve. Last call, I told you guys about VPD that does not necessarily exist, which is definitely the case. It always exists on cards that we manufacture, but we can't control cards that are just using our silicon. I also mentioned base MAC address. The problem with the base MAC address that although it's persistent, it always exists, there is no upstream tool to query for that. There is an NVIDIA tool, but we don't want that to be, the standard way, because it's not a standard way. So even a base MAC, a MAC is not a good option because the base MAC is not queryable without a proprietary tool, and any MAC that's not the base can be changed from software. So again, you will encounter a discrepancy between the two. So that's where things stand, and yeah, I would like to understand if it's the same with other vendors, and I can copy the link to this documentation to the chat, or you guys can just look at it. It's at kernel.org.
Yeah, you can copy paste it so I can
Okay.
put it in the meeting.
Yeah.
So I think at least from what I'm hearing is we can come up with standardization maybe based on MAC address, just throwing it as an example. But then the tool can be still proprietary by each vendor, so each vendor will have to provide some kind of tooling that can actually fetch the MAC address, and then we can do the matching. Because
I say MAC address because MAC address is something that has to exist. If your MAC address is, if you forgot to burn a MAC address at manufacturing, then you have bigger problems than matching between DPU and guest interfaces. You won't get a link up with MAC zeroed out. But again, I don't know if the notion of base MAC that we use is the same with other vendors. It can be, anything that's on the hardware itself. VPD serial number is a good example. We can decide that that's the way to go. I mean, we can promise that every NVIDIA card that goes out has a VPD. If someone buys the silicon and forgets to put it, then we can say you violate OPI spec. But even then, you
VPD
got,
is available on both sides. Like, can I query VPD on the host side and on DPU side, and then correlate, and or it's available on each physical and virtual and scalable function?
you can do RSPCI dash VVV on any physical function. You will get the VPD data, including the serial number.
Okay.
But again, what you were able to do here is to map between functions on the guest to a specific DPU in case you have more than one.
Mhm.
It didn't get you any closer to map between interfaces, right?
Yeah.
Yeah, so that's useful as long as you have VPD, and if you have more than one DPU, that's useful.
Then you have a hand up.
Yeah, I was gonna say MAC address doesn't really work because we need this for disks and NVMe controllers as well. So using a MAC address might work for networking, but I actually don't think it works for networking either, because if you allow your host or your guest to change their MAC address, which is pretty common, then then you lose that information and you don't.
Yeah, so I was talking about something we call base MAC, not the MAC address of the interface, but the base MAC. And base MAC is the MAC that we burn on the flash when we manufacture. The PF interfaces are derived from it, and it never changes. But again, in order to query the base MAC, you need to use the vendor tool. Otherwise, you might get any MAC that was assigned by the user. So you're absolutely right that this MAC should not be counted on because it often changes.
Yes, I don't think base MAC is something that's universal across. So the allure of MAC address is that every interface has to have one, but if it can change, then it doesn't really work. And also same thing for VPD, is that that's not something queryable from just any device. That would also have to be proprietary. So that also doesn't really work.
Why is VPD proprietary? It's defined by PCI spec and printed by LSPCI.
Exactly.
Right. So if you have a virtual device,
Of course, you have to work on top of it.
But
if you have a virtual device, you don't want the virtual device to be able to do that mapping. I mean, a virtual device is a tenant, right? It's a tenant on a cloud.
Right, and they shouldn't have access to the VPD of the IPU DPU thing. So that's why VPD probably doesn't work either. Is that depending on your deployment, you may choose to expose the VPD and have that VPD map to the hardware, or you may choose not to. And I think that the more common case would be that it wouldn't map to the hardware. That you're going to have to do this mapping at a higher level. You can't just try to use something, some sort of BKM on the platform to do the mapping. You'd have to map. If you have software that needs to coordinate between what's on the host and what's on the IPU DPU, then that should happen at a higher level in orchestration, and not try to use how the devices are presented on the PCI bus.
Right.
But we are talking about that problem. We're talking about high-level orchestration. Let's say Kubernetes controller that we talked in API workgroup, right? So some piece of external orchestration system that wants to do the mapping. So it comes from outside to the server and outside to the SmartNIC. And he wants to map between interfaces here and interfaces there. So it needs to have some way to identify which functions belong to which functions. So how that high-level application that we develop in the orchestrator, how it can know without us helping it to know. It will maintain the mapping, that's fine, but we need somehow to identify that this belongs to this.
Yeah, and that's why I posted that PR last week, is that I don't think that you need to have some sort of implicit BKM for identifying the devices. You should be able to, based on your orchestration, communication between the host and the IPU, DPU, you should be able to coordinate at the orchestration level based on knowing what kind of device it is, what the handle for that physical function is, and what VF number you have, and then what subfunction you have. So that should be sufficient for the function either on the host side or on the infrastructure side to figure out which device this is and where it should be hooked up into the next layer.
But again, what you're saying is we need standardization and a tool that you can run on the DPU and on the server that will produce you with the same result of triple that you suggested, right? Physical, virtual, and scalable, whatever, subfunction. That will produce you the same result when you give it some virtual or physical function, doesn't really matter. So you can actually write this. So this is what you're saying, and I don't understand what the solution is.
Boris, can you maybe after the call or now explicitly outline the problem definition? And because we switch between provisioning and runtime, and so if we can have a clear problem definition, we can go and maybe think about it offline.
Mhm.
I think we probably need to start from the application itself. So probably be easier if we said, hey, we're going to make this work for OVN, whatever, I don't know. And then break it down from there and then find the bottom part of OVN. And if it's doing it in a way that is sort of maybe specific to each vendor that supports OVN or whatnot, then that's probably where we could, start writing the code to go and come up with a standard there so that, future versions of OVN don't have to do it the per vendor way, but they can do it the OPI way. So I would try to start with that, is to figure out what our driving open source application is, or even if there's a closed source application that wants to do it this way. But I would try to drive it from the top down so that we don't just sort of we don't miss the requirement from the application vendor or the application developer who is trying to just do it a standard way, as opposed to having to go open up the details for each of the different vendors.
So one application and one use case I already posted in the Slack, which is OpenStack. OpenStack today has an auto discovery method that unfortunately relies on VPD today, right? So that's a well-defined use case. I posted the links. I can post it in the chat here as well. So for people to go and look at this, but this is one of the well-known application orchestration stacks that we are talking about. So OpenStack with
But that also used MAC address, right? So it's only for networking.
Yeah, I know. Okay. So you asked for an example. I'm giving one example, right?
Yeah. So I think OpenStack is a great one. We can start there and take these sort of existing maybe implementation specific solutions and kind of come up with like the OPI way to do it in a more standard way. I would love that.
Yeah, and just so people can actually see that, I'll share, right? So when you read this page on SmartNIC with OVN, right? So we have these pictures with Nova configuration, and the auto discovery is talking about that, right? So they take in the card serial number, the physical function MAC address, and the virtual function logical number, and this is what they use to identify. And they are talking about serial number being very crucial in the scalable system to actually, they use that to identify which DPU belongs to each server as well. Because you're running from the outside OpenStack controller plane, so you're having all this information available to you, so you need to actually make sure that you understand which functions belong to which servers. So this is why they use this triple. And I personally don't think this is a good solution for us. So if we can improve that and standardize on something better, then we can, I think it's going to be a much successful story. Makes sense?
And I think if we could solve the problem, not just for OpenStack, but for OpenStack Ironic, so it can work for bare metal hosting too, in the same way, I think that really moves the needle, right? In terms of, maybe not too many people are excited about OpenStack by itself, but to be able to, you really have a hard time doing Ironic without, an IPU DPU. So if we could find a solution that could also incorporate bare metal hosting, I think that starts to be really interesting.
I will second that, and not being a longtime project leader of Ironic, but mainly a lot of the feedback we're getting is people just will not allow separation of duties to be programmatically managed in terms of network management. So the only way to abstract yourself out of that problem is to have like an IPU or DPU module that can be programmed remotely.
Yeah, that's good. And as we all know, in our API work group, we're talking about Kubernetes as additional use case. So Open Kubernetes, and the same need came up. If we want to provision the MAC addresses and IP addresses, we want to provision the Open Virtual Switch. So we need to know which functions will be pluggable to which pods, and then we need to understand what their representatives are on the DPU side, so we know how to plug them into the switching offload of engines. Yeah, that's good enough, or you need a little bit more details?
I need to look at it more details, but yeah, if you can outline the problem definition, then I can take a look at it offline with a bunch of more people and see if we even think that's a problem. Maybe it's an operator problem and not something that the industry should solve. I don't know. Yeah, if you can outline it clearly.
Yeah. Okay, I'll try to do that. Okay, any other feedback on this topic before we move on to the next one? I see Marvel posted in the chat the proposal for the struct. Let me share that. Not sure if everybody saw that. So this is Marvel. So they propose this kind of interface, a BDF with a MAC ID, bus device function, and they can accommodate that into different tooling, like maybe DevLink that can provide you the same kind of information that you can run and get the information of. So just encourage people to look in the Slack and see what's going on. Okay. Let's move on. Let's just quickly touch on the reboot sequencing again. This is a kind of new page I created maybe already 2 weeks ago. So this use case is talking about 2 flows. One is DPU reboots, and one is what happens when host reboots. So when DPU reboots, we want to notify the host. So why? First of all, during the DPU rebooting, host can just, yank DPU power. So we want to somehow notify the host, okay, DPU is rebooting now, so please avoid as much as possible for removing the power from the DPU. Then we can also, if DPU wants to reboot and providing notification to the host can take some action to migrate the workloads to another host or another DPU while this specific DPU is rebooting. And also we see that when DPU is rebooting, especially the PCI Express responsible firmwares or softwares, then basically host can crash today. Even having downport containment, the host OS can crash. So we want to raise kind of notification to the host that DPU is going to reboot, so host can prepare itself for the reboot and not to crash. We want to notify the host to allow DPU to actually collect its core dumps as well. What I mentioned here is host can either stay alive or gracefully reboot once DPU is rebooted. It's host kind of choice to do so. So how exactly I propose this to work? So
quick question. How would the host yank the DPU power?
Through the iDRAC, right? iDRAC can yank the power from the DPU.
So that's not the host doing it. That's the BMC.
Host is doing IPMI power cycle, and then everything dies.
Right, but that's different. That's the host being power cycled. But how would the host be able to do anything directly to the DPU? It would have to do everything through the
It's not. It's the platform BMC.
Platform BMC, yes. So I'm not saying the OS notification, maybe it's BMC that needs notification, but what I'm saying, host, either host OS or platform BMC. Yeah.
I mean,
that's my question. How would the host OS do it?
well, when the OS is shutting down, requesting a termination, it's calling, UEFI runtime, right? And UEFI runtime, can't remember all the little pieces that are involved, but from there it may directly request that the power supply shut off after it exits, right? So,
but I think even the simple IPMI tool power cycle will yank the DPU power that host OS can request through the platform.
No, but I'm just saying the host can't specifically request for the DPU to go down. It doesn't have
if the DPU is receiving power from the same power supplies that are in the server, right? Then when the host requests that the power supply shut off, tells it to basically go main power shut off, and the only thing available is aux power, right? There's no way that aux power is going to power a 75 watt or whatever DPU.
Yeah, I know. I think it's a semantic thing. It's just that the host here is not yanking the DPU power specifically. I think this really needs to be about what happens when you have shared power and the system powers down. It's less specific to DPU and more specific to, hey, I have a high powered card here that might be running software and during a reboot. So just the why is a little confusing, because it if I read this, it makes it look like, hey, I want to give the host a capability to go in and reboot the DPU because I'm debugging it or it's broken or whatever. And I is that what you're saying? I don't think you're saying that.
Well, okay, so depending on how you make the platform, it might, right? Like if you can disable a PCIe slot, you might be able to essentially yank the power of a DPU, right?
But what if the DPU has external power supply?
Yeah, I mean, it's how you design the entire system, right? So yeah, you can't.
We can definitely refine the language. I'm fine with that. But there are use cases at least with a shared power supply, then you turn off the power supply and the DPU loses power. So we want some kind of coordination. That's what I'm saying. I'm not saying it's applicable to 100% of the use cases, and maybe yes, language need a little bit of refining here. This is just a first draft that I threw together.
Okay.
So all the feedback is very welcome.
Like want is great, but if this coordination is expensive. I see the diagram. There's lots of things going back and forth. Like I think that the why needs to be really crisp. Like it when you do these power cycles today, does something go wrong? Like, shouldn't if the DPU IPU knows that it's going to be living on a shared power supply, shouldn't it be designed to be able to lose that power at any time?
So if you were to just take a channel DPU and stick it into a channel server, right? When you shut down the system, more than likely the DPU is just going to see a surprise power outage, right? It's, you know, the OS will get to gracefully shut down on the server, right? And there won't be much of an indication other than a PCIe reset at some point during that when the driver unloads to let you know, hey, I'm about to lose power here, right? You're just gonna all of a sudden. So what can happen is you can end up with DPU file corruption, right? Because it's like he's getting his power yanked all the time.
So power yanking is just one thing, right? But look at the other things as well, right? So today, if you reboot the DPU PCI Express domain, right, the host will reboot itself, will crash, right? Because of the downpour container today, Windows, Linux, VMware, right? You are just experiencing surprise removal. That is not really working well for NICs today. So this is another case. Or DPU can be in the middle of core dumping, and then you reboot DPU. So all these use cases, I think that we need to at least discuss. If we, after the discussion, we find out we don't want to solve any coordination in this space, that's fine. But what I'm suggesting here is why I think it's valuable and open for discussion at every single point here. And I'm probably missed couple or misspoke for a couple of those. But this is my initial draft, like why DPU needs to notify before it reboots to the host, and host can be CPU or BMC. So that kind of, yeah, look, that's a good comment, right? So I think I did that in a TLDR. So if it's not clear, please, everybody welcome to propose pull request and enhance that. I cannot drive all these pages by myself. So everybody feel free to jump in. Yeah.
Perhaps we can say the ACPI S5 state instead of saying host powering off.
Mm-hmm.
That probably makes it more clarified.
Yeah, sure. So everybody who wants to clarify things, all the pull requests are really welcomed. Go ahead, clarify. I'm taking this time during the face-to-face meeting in order to, explain what my thinking is. And if people find my explanation useful and they want to be on paper more useful, feel free, for sure. It's all collaboration work at this point. But again, back to the use case the use case is talking about DPU wants to reboot itself. Should it or should not it notify somehow the host, and the host can be either OS or the BMC. Should it notify that I'm going to reboot? Host can then, right? So how to notify, there are a couple of mechanisms, in band, out of band, I think very similar to what we discussed in the initial boot synchronization. And then what happens when DPU actually notifies I'm going to reboot? So host can do nothing. Host can request postpone of reboot that DPU can ignore or accept. It's depending on whether it's trusted or non-trusted environment and stuff like that. But basically, this coordination, this is what I had in mind for the use case when DPU wants to reboot itself, whether it's discovered some problem or Linux kernel crash dumped or something or automatically upgrade happened, which uncoordinated or something wrong happened with DPU. Yes, Dan.
Yeah. Okay. So you're actually talking about not the host losing power, but actually the DPU resetting.
DPU reboots. Yes. DPU reboots. This is a use case. When DPU wants to reboot, he wants to notify the host, I'm going to reboot. So host can take some action when DPU wants to reboot.
Okay. When an IPU reboots, it just has to follow all of the specs on the PCI side so that it can reboot the pieces that it needs to reboot without upsetting the already enumerated PCI interface. So there's a procedure there where the IPU can reboot. But you have to, if you're going to keep devices in the PCI bus during that time, then you need to take care of that. So
How you take care of it? DPU needs to notify somebody that this is going to happen. So somebody can take an action of taking care of those devices.
it doesn't tell the host at all, because the host is untrusted. So in the IPU case, we can do all those resets, the different levels of how much do you want to reset, but reboot. But we don't
I'm not talking about ARM reset. I'm talking about PCI Express root complex that actually, doing some harm to the host. Yes.
Right. And so the easiest way that we've done this in the past is just to support hot plug in the BIOS.
You cannot support surprise removal on NICs today on Linux. It doesn't work.
Oh, it's not surprise removal. It's hot plug. So all the OSs support hot plug, and so you can hot unplug all of your devices, reboot, and then plug them back in. That was one example.
I don't think all current servers, right, support hot plug,
Often
and that's
Servers,
SSDs, yes.
you have to set up in
SSDs,
the
yes.
BIOS.
NICs, no.
Yeah. You have to set up in the BIOS, but once you do that, the OSs support hot plug, because hot plug is what KVM uses to hot plug devices into VMs. It's the same mechanism actually in the
It's
OS.
different between hot plug and surprise removal. When you try to reboot today, and we tested it, right? When you try to reboot today, the Linux kernel will crash.
Absolutely, yeah. Surprise removal is not working, so you have to use hot plug instead. And so that's one solution that you can do. You can also, if your system is able to, you can keep your PCI devices up and just reset everything else behind it. And then your system needs to be smart enough to know, okay, I just came back up and these 7 devices were already in place. So how different is that from the configuration that I want? And is this a system that can do a hot plug? Or is this a system where the enumeration is fixed?
So your opinion is we don't need to do any coordination. I understand. This is what you're trying to say.
No,
We don't need
it's
to
a
do
lot
any
of work.
coordination. Let's just finger cross and make it work.
No, it's a lot of work actually. These are the problems we spend the most time on. But we just have to understand the constraints. Like the constraint in an IPU is the host is untrusted. You trust the BMC likely, and so if there's coordination you could do with the platform BMC,
Which is what I mentioned here, right?
Right,
Out of band via platform BMC, yes.
So that is possible.
We need first to agree that we need to do coordination. Then we need to agree who we're doing coordination with. Then we need to agree how we do the coordination. And then, whether it works useful for all the use cases. Makes sense?
Well, I'll also say if you want to trust the BMC, but you don't want to trust the host, you're going to have to do some things on the BMC to isolate it from the host. Because by default, they, standard BMCs just allow passwordless actions to come over the KCS bus, right? So from the host, if you have root access on the host, you can usually do whatever you want with the BMC.
As a data point, we're now seeing firmware shipped from vendors where that interface is disabled out of the box. Some cases where that interface just doesn't exist anymore. And it is becoming quite interesting.
That's good data point.
Consider that, or you need to, if you want to create that separation, you have to say, hey, I need this separation.
Absolutely agree. Only very specific vendors or operators will even turn that off after the fact if it's on by default, and their vendor doesn't turn it off by default.
Yep.
The question that I have to the group, do you feel that this is important? Like we talked about initial boot synchronization, like when everybody just powers on and we need the host to wait for DPU to boot before it can continue booting. So that initial coordination. Do this group feels like this use case is important to deep dive and continue to solving? I just want to get feedback from people to see whether they feel it's useful.
I think it's an important use case, and we should definitely have a more detailed discussion on this.
This is
I
Risa.
agree
do
with that.
agree.
I also agree with that. This is an important thing to have a conclusion on. The use case Dan is describing is likely the cloud use case, in which case cloud orchestrator can probably move some workload before any such planned event happens, but unplanned events is a different thing. But I think there are use cases in non-cloud type of deployments where host and IPU, DPU are not that segregated or separated out from security point of view.
Thanks,
So ultimately, we need what is the behavior, and it's okay to say that we won't do anything and we'll build products that never crash. That's a good strategy. I don't mind that, but at least we have to agree on one.
I would say that we have a lot of work to do in provisioning, and we haven't really come to the kumbaya moment where we say, hey, these 4 vendors all agree that they're going to be provisioned in the same way. Now, I think that this timing race, where for some devices require the coordination, I think that's an important detail for those devices, but I don't think that it's the first order bit for what we're doing in this work group. Like I think that has certainly been my feedback back to, Rob and others, is just that, we are not yet working on the main piece of like, hey, the easy thing to describe at the SmartNIC Summit in June would be, hey, we came up with a provisioning model that works with these 5 vendors. Yay, you can all provision them in exactly the same way. And we are not making enough progress on that because we are sort of I believe we've been over-indexed a little bit on this coordination issue, because I know that it's a pressing topic, but I do think that our cycles would be better spent, trying to get to that, first order, like provisioning in a consistent manner across 5 vendors.
I can comment to Dan, but I heard Risa, you also commented something before. Just don't want to lose your comment.
Yeah, so I do agree that we need to, solve this boot coordination and reboot coordination issue. As a system vendor, we cannot integrate a DP or a smart IO card into our server until we solve these problems. And so what Dan is saying is very important. We need to get to that provisioning step as well. But from a system vendor point of view, we can't get to provisioning until we solve these problems.
I agree with Reza 100%. This is also Delview as a system provider, same as HPE. We cannot continue walking around this issue, and we need to solve this coordination. And this is what I also received from TSC committee indication, that this is the most pressing issue to resolve and the most important one so far. So I understand then what you're saying, but then you need to coordinate with TSC. Yes.
I'm not disagreeing with that, but what I'm saying is that it needs to be couched in that way, is that we're going off to solve this specific problem. And then once that's solved, then we can start to focus on the provisioning for all topic. But I don't want to get the provisioning for all confused with solving this specific coordination issue. And, I think it's fair for a particular vendor, Intel, to say, we don't have this coordination issue, and that we're okay working on it in OPI, but it's not an issue that we have. And we don't want IPUs and DPUs to be assumed that the only way you can make it work is if you have your host coordinate the boot with your IPU DPU. That's my main concern. As long as that's really explicit and people understand that not everyone needs this coordination, but it's always good to have, and it's critical for getting a multi-vendor ecosystem, then great. But I just don't want it to get mixed up where people assume that all IPs and DPUs require this feature from the platform vendor.
Yeah, that's obviously Intel choice to participate or not to participate for sure. And again, if you're confused, then this is the first page that we're talking about. So discovery, provisioning, inventory, boot sequencing, lifecycle updates, monitoring, telemetry. So we've been working in parallel on all of those. So yes, currently we've been taking a lead on the boot sequencing topic, boot coordination, which was indicated as the most important one from participants in this forum and also from the OPI-ITS committee.
I think just to reiterate, I'm not saying that we're not going to participate. I'm saying that our messaging to TSC and whatever we produce out of here needs to be explicit that this is a workaround to an issue that certain devices have and certain devices don't. And it's not a requirement that in order to put an OPI IPU DPU into your system, your platform vendor has to support this booting sequencing thing that we defined. It shouldn't be a requirement for all devices. That's all I'm saying.
And I'm saying that when you tape out your Mount Evans, then we'll have another discussion. We'll figure out how it works. And if it works great, I'm all forward for it. Yeah.
No, that's not what I'm saying. So are you disagreeing with me with that? Or are you in agreement that we can communicate this out of the work group that we are doing this boot sequencing because it's an imperative for the platforms to be able to ship certain DPUs? Do you agree with that statement?
I think we're beating the dead horse. I think we understand your position. That's fine. Let's just move on. I want to finish this page, and because people indicated this is important. Okay, so this first use case is DPU reboots. We listed several whys. We listed several whats and several hows. I wanted just to comment to Reza previously. So why I did this exercise for the DPU reboots new use case, because I think that it's interconnected with our first proposal of initial boot sequencing. So if we're doing different kind of messaging during the DPU reboot, or we choosing to do the same messaging during the initial reboot, I think it's going to be important, right? So if we can solve in-band, the first use case like you proposed over PCI Express and you class with a specific register defined, so we can see the coordination and the progress, we need to try to take another shot and this use case and then see if we can solve it in the same way. And if we don't, that can impact our decision-making on which actually interface to use. If the only way to resolve this kind of reboot coordination is out of band and we cannot resolve it in band for some reason, I don't know what it is, but if we cannot, then maybe it will affect our initial boot sequencing to be also out of band, because obviously we don't want to develop maybe two interfaces that do similar things. Make sense, Reza?
Yes, it does. But we do need to consolidate the two.
Exactly. So I wanted to start this page in order to see, like, maybe change a paradigm, because I was thinking we kind of stuck in the three options that were presented for initial boot sequencing and we're not moving forward. So I wanted just to expand our scope into this, and maybe this will help us to make a decision in the right direction. So I provided a quick diagram of how it looks like. Again, not the best diagram I can come up with, but yeah, this is the coordination. So basically DPU can request, can notify that reboot is going to happen, and server, BMC maybe, can postpone, request the postpone the reboot, and then DPU can either honor or not honor this postpone request. And anyways, after the timeout, DPU will choose to reboot itself anyways. So this is kind of first draft of this page that I prepared. And I cannot emphasize this enough. So everybody who has an opinion or wants to enhance it, please feel free. The last use case on this page, or the second use case on this page, is what happens when host wants to reboot itself. Does host need somehow to notify DPU that the reboot is going to happen from the host perspective? And I'm not saying we need any additional methods. If there is already a good method that exists today, we can definitely leverage it. But I'm just trying to see if this use case is also important. Somebody indicated to me that there are some resources or context that can be associated with specific host. So if host wants to shut down or reboot itself, so DPU would like to be notified about that in order to free some resources or context associated with that host. And then it can kind of re-provision for the next tenant, or maybe even DPU can deny or prevent host to reboot itself, like in a cloud multi-tenant environment, something like that. So I didn't have a lot of time to work on this, but I think that's a second part of DPU wants to reboot versus the host wants to reboot itself. Is that also useful that people find, or less?
So a host wants to reboot is something that, you know, just happens today without PCI adapter cards,
Mm-hmm.
and it's fine.
And you use in P reset, right?
Function level reset.
Function level reset. Okay.
Yeah.
So yeah, if that's a good method, we can just, you know, write one sentence that this is agreed upon everybody, that function level reset, this is what we use, and this is how DPU is being notified about host reboot, and then it can do whatever it wants with it. And this is a standard that we're using. We don't need to reinvent the wheel if there is problem is already solved.
I'm wondering if there's another use case where the host wants the DPU to reset, but I'm kind of struggling with it. What Dan said earlier is that the host is not trusted. So I'm not sure if that is a valid use case, but I'd like to hear the opinion of the folks on the line.
If you ask me, I think that DPU exposes management endpoint, and one of them is, you know, update firmware, and another one is reset itself, and we can identify a couple of different levels of reset, and then according to who is allowed to send this management commands, whether it's external management system, which is authenticated and allowed, or host, which is untrusted and disallowed, I think it doesn't really change anything from the DPU perspective. Yes, Dan.
Yeah, it's just if we're talking about open programmable infrastructure, then you know the infrastructure. There's this red line that we drew between the host and the infrastructure, and you know, by default, certain devices make the host untrusted. You can build up trust at different layers of software, but you know, just because the host has root access doesn't mean that they can access your IPU by default. So that's really important. That's sort of fundamental to the I in IPU as infrastructure. You know, I think that we have to keep in mind what our use case is in order to say like, okay, well, well, you can't just assume that the host can choose to reboot in different ways. You know, that's they can reboot itself, but it, you know, you can't assume that it knows even that a DPU IPU is hanging off the PCI bus at all. So that's why you know, this document is very confusing in the way it's written, because it just makes a lot of assumptions about what like what mode these devices are running in.
I definitely agree. The host should be considered untrusted by default.
Yeah, I second that statement as well. And that's a good point. I think that we have a fundamental picture on the very first OPI page, that we have a clear demarcation between the host domain versus the IPU DPU infrastructure domain. So I mean that if host OS or the host domain manipulates or sort of reboots the IPU DPU device, I mean that itself brings some security vulnerabilities as well. So yeah, we need to be a bit mindful discussing all those different use cases. Thank you.
Thanks, Alok. So Eyal, back to you on this host reboot. So do you want to put a kind of sentence or couple of sentences how you envision this function level reset works, and maybe just point a link to some documentation, and then we can close this second bullet and say this is what we're following.
Yeah.
Okay, thanks.
Yes. I don't think we can use FLR here because again, if you don't trust the host is only getting virtual devices. It can FLR an NVMe controller or FLR a port, and that port can reset if it wants to. But that would have no effect on the DPU IPU itself, because
the operating system issues FLR. You have no control over that. You can take the decision to do nothing with it.
Yeah.
You may have to do something if it's bad for you that the host is going down. Like for example, if you have open memory pages or stuff like that. But you know, you can decide what to do with it. It's up to you.
Yeah, and this I think is where we need to standardize the expectations so the host doesn't think it put an FLR on an NVMe drive it knows is attached to an IPU DPU, but then the IPU DPU doesn't reset and only reset the NVMe device.
So the host doesn't necessarily even know that it has a DPU. So it says,
exactly,
I don't know, it says Intel device. Maybe it's not a DPU. It doesn't know anything. As you said, it's infrastructure.
Yeah.
Okay, I got to drop. I have someone at the door.
Thanks, Dave.
Yeah, put the action item on me on Slack, okay? Thanks, Boris. Bye.
Bye. All right, so I think we're out of time. This was good. We went through this page, and we'll continue next week. And sorry, Summer, we didn't get enough time to get to your topic, so I promise you that next week we'll start with your topic first. Thank you, and see you next week.